Hello, physical science fanatics, grade 12 learners and teachers and anyone interested. Another session, another informative session. Remember, knowledge is power, so little information is very dangerous. So let's explore more so that if the assessment come, we would have been exposed to many similar questions in the past sessions. One question is question number 2 in the organic molecules in paper 2, which deals with nomenclature, isomerism, functional groups, homologous series, and naming. This is the question. They say in the recent question paper, they say letters A to E in the table below represent 5 organic compounds from different homologous series. Now remember, simply you just have to analyze this table before you can attempt the questions quickly, knowing that now doing that you will be really saving a lot of time in the answering of the questions. Number 1, you can see that this one is an alkyne, therefore it will have the homologous series alkyne, and then the general formula will be your CN. CnH2n minus 2, and we can even name it quickly to say 1, 2, carbon number 2 is the iron, and then at carbon number 1, 2, 3, 4 we've got methyl, so we'll have 4,4 methyl, a dimethyl, and then in a pent 2 iron structure. Then it's your 4,4 dimethyl pent 2 iron. That's the case. The second one, the second one, number B, is an ester. You can see this one quickly, that is methyl. The alcohol side will be on the right hand side, ethanoate, which can be also the functional isomer of propanoic acid. This one is C3H6O. Remember, this one therefore is either an aldehyde or ketone. If it's aldehyde, it will be propanal. If it's a ketone, it will be propanone or propan 2-one, sorry. Fine. And then this one is a butane, is a saturated hydrocarbon, which is 7C4H10, and then we'll have the general formula of CnH2n plus 2. And the last one, which is number E, you can see that it's a haloalkane, Br and fluorine. And the fluorine, since it's at carbon number 1, therefore we'll start from this side, 1, 2, 3, 4, 5, 6, hexane. And then fluorine is at carbon number 1, we'll have 1 fluoro, and then methyl, 3 methyl, and then again 5 methyl will be 3,5 dimethyl, and bromine is at carbon number 5 as well, 5 bromo. Therefore Br becomes before F. Therefore name of this one will be now your 5 bromo and dash 1 fluoro, and then dash 3,5 dimethyl in a hexane structure. Very long name, but no problem. It will be 3 marks hopefully. And now let's answer the questions. You look at question 2.1. So if you have done this analysis, short analysis, take it 5 minutes, will be fine, and then it will shorten your answering now. Define the term homologous series. Taking from the examination guideline will be now a series of compounds, series of organic compounds, that with the same general formula with the same general formula, and that can be represented by the one general formula, or this, if you don't want to say same general formula, you can say functional group. Okay, or you can also say in which one member differs from the next with a CH2 group. That is the homologous series. 2.2, yes, 2.2, they are saying to us, write down the letter that represent a compound that is, hopefully from the analysis 2.2.1, they say saturated hydrocarbon, we know it's D, we've already done that. 2.2.2, a simplest of its kind, so which means that is the first compound in its homologous series, the first member of its homologous series. The lowest will be your, in this case, will be C, which in terms of the ketone, C will be the first member of the ketone group. Ketones, in that case, C will be the best in this case. And 2.3.1, 2.3, they say to us, for compound A, we focus on compound A, remember, we have already analyzed it. Write down its molecular formula. So we said 1, 2, 3, 4, 5, so it's C5. And sorry, not C5, how many carbon atoms? So 5 plus 2, C7. And then because it's an aldehyde, we can, as long as this one is 7, then it will be 14 minus 2, which will be 12. So the answer is C7H12. That will be the case. 2.3.2, that's saying to us, for A, rather than the condensed structural formula, you look at that compound, we start from the right, CH3, and then C, another C, and then there we've got two branches, CH3 times 2, and then CH3. So I think that will be the case. You can start this side, finish this side, or start this side, finish that side. So it's fine either way. And then for 2.4, a compound B. You look at compound B. Remember we said it's an ester. Rather than the UPEC name, we've already done that in our analysis. We said it's methyl ethanoate. Methyl, remember the alcohol side will be this, and then the acid side will be the one with carbonyl. So acid side has got 2 carbon atoms, that is coming from ethanoic acid, and this one is coming from methanol. Hope it's familiar. The next one, write down the type of reaction to prepare it. We know this is our esterification. Others will also call it condensation. That will also be accepted. 2.4.3, write down the chemical formula of the inorganic acid used to prepare it. Remember, one of the reagent in this is sulfuric acid, but they need a formula, not the name. Therefore, you have to write H2SO4. 2.5, write down the UPAC name of E. We've already done that for E. We said E, it's 5-bromo dash 1 fluoro dash 3,5 dimethyl in a hexane structure. I think we have done that. It's very long, it's fine. So fluoro has got U, so there's fluorine, sorry for that one, should be fluoro, fine. The next one, which is the last one, 2.6, draw the structural formulae of the functional isomers of C. Now we go and look at the C. We said it can be a ketone or an aldehyde. Now they need the structural formula of the two. If it's a ketone, we'll be having 1, 2, 3. The one in the middle will have the carbonyl, and then the remaining bonds are for hydrogen. Each and every carbon should be surrounded by 4 bonds, don't forget. And the second one will be now an aldehyde. Remember, in an aldehyde, the functional group is on the first or on the last carbon. So the functional group, which is for mil, will be this, and then the remaining bonds are for hydrogens. This is the case. So it's just that they didn't say name them. We know, as we said this one is propanone or propan-2-one. This one will be just propanal. If they ask us to give the name as well of this one. So I think that's the long and short of it. Very good question of question number 2. We'll pause and then we'll do the other questions that are coming in this one. So maybe we can do that. The next question, I hope it will be visible. Sorry for writing on top of the question paper. Now it has jeopardized this question paper of mine, so hopefully we'll see. Now let's just quickly answer this one. It's question number 3. I think we still have some time. Question 3, they say to us a vapor pressure of methanol, methane and methanoic acid were determined at 20 degrees Celsius. The vapor pressure values are recorded in the table below, randomly marked ABC. The 3 compounds are used to investigate the factor that influence the vapor pressure of organic compounds. A vapor pressure were measured under the same conditions. No problem. That one is done normally for a fair comparison. Now, given ABC, this is 42.6. Sorry if you don't see that one is 42.6, and the second one is 316, and the last one is 723. So that's the highest vapor pressure. So remember, the vapor pressure increased from A to C in that case. Remember, the higher the vapor pressure, the lower the boiling point, and then the weaker the intermolecular forces. So first question, they say to us, define the vapor pressure. Now, definition of the vapor pressure, remember, we take it from the examination guideline. In this case, the vapor pressure will be a pressure exerted by vapor. So this will be the case. It will be a pressure exerted by vapor. at equilibrium with its liquid in a closed container. Very important, the container must be closed system in this case, in a closed system. So pressure exerted by vapor, that will be keyword at equilibrium with its liquid, key, closed system. So all the three keywords must be there. 3.2, and let's check. They say to us, for this investigation, write down the 321 dependent variable. That one is obvious. There are only three dependent variables in this section. That's vapor pressure, boiling point, and melting point. Therefore, this will be the vapor pressure. Yes. And 322, write down the investigative question. Very easy, without any haste. We just write what is the relationship. What is the relationship between the two variables, between the vapor pressure? You can start with any, remember, otherwise you can start with the independent variable, or in this case, because methanol, methane, and this one, it will be between this one and a type of homologous series, that's what is different, or type of functional group, or again the strength of intermolecular forces, You have got very many options there. The independent variable can be the type of homologous series, or the type of functional group, or the strength of intermolecular forces. So very important. 3.2.3, now they are telling us in this one to say, write down the phrase from the above paragraph which shows that the investigation was conducted fairly. If you look at this paragraph, then there is a last statement which says the vapor pressure were measured under the same conditions. So the phrase will be vapor pressure were measured. I just have to copy, under same condition. That was a bonus question. Or a learner can say, can even be explicit and say, now they call this one, what was controlled there, to say the compounds have the same number of carbon atoms, C atoms. That will also be very good. Remember, we are comparing methanol, methane, and methanoic acid. They all have got one carbon atoms there. Now 3.3, they say to us, which compound ABC is methanoic acid? That will be the one with the stronger intermolecular forces, must have the lowest vapor pressure, which will be A. Explain your answer. Then now, when you explain the answer here, we'll be now looking at 3 points. One, methanoic acid has strongest intermolecular forces. And then number 2 now will be it requires most energy, English there, to overcome the intermolecular forces. And then the last point there, hence it has got because it has the lowest vapor pressure. I hope it's understood. The last one, 3.4 for 2 marks. They say to us, the boiling points of methanol and methane are now compared. Which compound, methanol or methane, has higher boiling point? Give reason for the answer. So the one with the higher boiling point would be the one with the stronger intermolecular forces, with the methanol. And then the reason will be now for it has got the stronger intermolecular forces than methane. Or you can say because it has got hydrogen bonds which are stronger than London forces in methane. So in this case we have got that option again. So, or its molecules requires more energy to overcome the intermolecular forces than in methane. So you'll have such options in this case. Very nice question, which has got a lot of options as well. Don't forget to subscribe, and also can rewind this if you don't answer, go back and then so that you get clearer understanding of these concepts. Good luck until we meet again. Thanks. Bye.